Welcome to this third part of the motion. In this, we will be defining displacement and distance. The difference between displacement and distance, basically. Before making you understand the meaning of displacement, I would like to define a number line. You must have seen number line in class 6th or class 5th. That number line is like this. Here there is a 0 marked called origin, and numbers are marked on this line like this. And on the left hand side of the origin we have negative numbers at equal distances. That is, all real numbers can be represented by a point on the real number line. This is real number line. That is, suppose this is a point on a real number line and its value comes out to be 2.5. Suppose. That is, if we want to represent plus 2.5 in this real number line, we just mark a point here, and this is called the location of 2.5 on this real number line. Now suppose we do opposite. That is, suppose a point is given. We want to find out the location of this point. With this point there will be associated a length from origin. Suppose its length comes out to be minus 2.8. This minus 2.8 is called coordinate of that point. That is, we mark a point and we measure its value from origin. That measurement is called coordinate of the point. For points associated to the right of the origin, all the marks will be positive. Points to the right are positive from origin, and points to the left are negative. That is, suppose a point is given here, then its value from origin comes out to be 0.8. Then this 0.8 is called coordinate of that point. It is simply a nomenclature of that point. And opposite also, if you are given a coordinate plus 5, you want to locate it on a number line, then this will be the location of coordinate plus 5. Similarly, negative numbers are to the left of the origin. This is origin. Now in terms of this real number line, the position of an object can be defined. Position of an object moving in a straight line can be defined using this real number line. How? Real number line. Suppose a car starts from origin and moves straight to the right of origin and moves 4 kilometers. So on this real number line we will mark some numbers. Suppose this is 2 kilometers, this is 4 kilometers. So the car has now positioned this one. This one is the new position of the car. So position of car is equal to 4 kilometers away from origin to the right side of origin. So by this number line we can define a position of an object for an object moving along a straight line. Similarly, if the position of the object is given negative 5 kilometers, we can locate a point on this number line. Suppose this is -2, -4, -6. So the position of the object will be here. This will be the position of the object with respect to origin. Position. It will be -5. So this is how we define position of an object on a number line for a object moving translatory motion in a straight line. Now suppose, now I give you the definition of displacement. Displacement is simply the change in position of the object. In position. I will define displacement initially with respect to straight line motion as for one dimensional straight line motion, and then we will see the general definition of displacement but for understanding the basic concept behind displacement, it will be helpful for us to go for a straight line one dimensional motion. Suppose now this is our number line. A car is moving from origin. This is origin. The car is moving from origin and goes to the right of origin up to 5 kilometers. Suppose this is 1, 2, this is in kilometers, 3, 4, 5. So what is the position of the car? Initially position of the car was initially origin. Now after movement, the car moves to the new position. This is the new position. The car does not stop here and it returns back to this point, +2. This is final position. Suppose this is final position, that is after this the car does not move further. So displacement is change in position. What is the change in position? Initial change in position is equal to distance. Displacement. Initial position was A, final position is B, this is intermediate position C. Intermediate position. So what is change in position? Position of B, that is final position. Final minus position of A. It is 0, initial. What is the position of B final? It is represented as +2. And final, what is the final position of initial position of the object? Initial position is origin. So change in position of the car is 2 kilometers, and this is called displacement. Right. So what is the displacement? Displacement is simply the change in position of the object. That is how far the object is from its starting point. And it is the shortest distance. In the above example, the car has moved from A, then to C. First is gone to B point, then it's gone to C point, then again return to the B point. So what is the distance covered? Total distance covered is equal to length of the path, length of the path followed by the particle, followed by the particle. In this case, length of the path is AB plus BC plus CB. AB is 2 kilometers, BC is 5 minus 2, and again CB is 5 minus 2. So total distance covered is 2 plus 3 plus 3 is equal to 8 kilometers. This is the distance covered, and the displacement is only 2 kilometers. Displacement shows change in position. And what is the position? Position is the location of the point with respect to a given reference point, and normally we call that reference point as origin. Right? So this is the basic definition of distance in displacement. Now suppose our motion is not happening in a straight line. That is, suppose car is initially here and it moves this way and comes to this point. So the length is equal to length of this, length of path. That is, we take a measurement along this path, then the whole measurement will give the distance traveled. Our final point is this. And what will be the displacement? Is equal to change in position. So initial position of the object was here, initial position was here, and final position is here. So the change in position is this. The shortest distance between point A and B. That is, if we join by a straight line between point A and B, then this will be giving the displacement. Kindly note that the displacement is shown by an arrow and it has a direction. Displacement is shown by arrow, The length of the arrow is called magnitude of the displacement. Arrow is magnitude of displacement, and its direction is called direction of displacement. So displacement has both magnitude as well as direction, but distance is only having a magnitude, is only having size or magnitude. Now for example, giving you example, suppose the body is initially here and it moves in a straight line 4 kilometers, then perpendicular to this line it moves 3 kilometers. So total distance will be distance travel is equal to 4 plus 3 is equal to 7 kilometers. However, displacement, that is change in position. Initial position was this and final position is this. The shortest distance between those 2 points is a straight line joining these 2 points A and B. And by Pythagoras theorem it will be under root 4 square plus 3 square is equal to 5 kilometers. So displacement will be will be 5 kilometers. For a straight line motion in which we represent a position in which we represented position by using a coordinate, suppose x, then displacement is equal to x final minus x initial for a straight line motion. This is only for a straight line. Kindly note that it is only for a straight line motion. Displacement is final coordinate of the body minus initial coordinate of the body. Final coordinate minus initial coordinate. So this is how we define displacement and distance. Now we take up scalar and vector quantities. Vector quantities. First, for understanding the quantities, first we define what are physical quantities. Physical quantities. What is a physical quantity? A quantity which can be measured. Which can be measured is a physical quantity. So like mass, temperature, volume, length, these are all physical quantities, but there are certain quantities which cannot be measured. Suppose just like our sentiments, pain in the body. We can say that pain is very high or pain is very low, but how much pain we cannot measure. There is no physical quantity which can measure the pain. So these are not physical quantities, and these are physical quantities, right? Physical quantities are described in two ways. Physical quantity I will represent as PQ. One is scalar and second one is vector. Scalar quantities are those quantities which can be defined just by a number. Can be defined using single number. Number which represents size of that which represents size or magnitude of that PQ, like mass, length, speed. These are scalar quantities. Mass, suppose the mass you have a 1 kg mass. Only one number is sufficient to tell that this is the mass of a body. Suppose the length of a body is 1 meter. Then 1 is sufficient to tell what is the meaning of that physical quantity length. Similarly, suppose the speed is 4 km per hour, then just by saying 4 km per hour it is sufficient to tell what is the meaning of that physical quantity for this number. So these are scalar quantities. There are another set of quantities called vector quantities. These vector quantities for describing these quantities we need size, that is magnitude, as well as direction. Suppose we say a 10 Newton force is applied. This statement is wrong because until and unless we know in which direction force is applied on the body, we cannot be sure about the movement of the body because of this force. So for defining force we need a direction. Suppose this is the body. A force is applied in here, a force is applied 10 Newton here, a force is applied 10 Newton here. If we define force just like this, we cannot be sure of the movement of the body due to this force. For defining precisely the movement of this force, we need what is the direction? What is the direction? That is, in which direction force is applied. Force is applied to know the direction of the body, to know the direction of movement, to know the direction of motion of the body due to this force. So for a force we need its size, that is magnitude, as well as direction. Similarly for a vector, so for a velocity we need magnitude as well as direction. We will define what is velocity in this series only. So what are scalar quantities? Oh, sorry, vector quantities. Vector quantities are those physical quantities which need both magnitude and direction to be described. So vector quantities are those PQs. PQ means physical quantities which require both magnitude and direction for describing the PQ. That is called vector quantity. E.g. displacement. Displacement is a vector quantity as we have already explained it. Is a vector quantity. A vector quantity is represented by an arrow. The length of the arrow is called the magnitude of the physical quantity, and the direction of the arrow is called direction of the physical quantity. Now we will define what is speed. You must have seen that while sitting on a motorcycle or sitting in a car, the speedometer tells a reading, and you say, Papa, drive this vehicle more fast, it will give us more enjoyment. Faster, faster. What is that? The what is that meter represent? That meter represents the speed of the vehicle. But what is the speed of the vehicle? What is the definition? The definition of speed is distance traveled divided by time. This is the basic definition of speed. This is the distance, not displacement. Not speed. There are two kinds of measurement for speed. One is called average speed, and another one is called instantaneous speed. Instantaneous speed. I will not define instantaneous speed because you are a class 7 student, but I will only touch what is meant by instantaneous speed. Average speed is equal to total distance covered by the body upon total time taken. In covering that distance. And what is instantaneous speed? Speed at any given time. Speed of the body at any given time. That is, when you look at the speedometer of your car, suppose the speed is telling 40 kilometers per hour, then you are looking at the speedometer at that particular instant of time, and during that instant the speed of the car is 40 kilometers per hour. Now suppose the speed of the car increases and you again look at the speedometer reads 60, then the 60 is the instantaneous speed of the car at that particular moment when you are looking at the speedometer. How to mathematically define in the instantaneous speed? We need some understanding of calculus, but we will not define here in your class 7 syllabus. Only you take that average speed is very important for you. Similar to the notation of average speed, we have defined total distance covered upon total time. There is a notion of average speed, and it is equal to displacement upon time. That is, you calculate just the displacement and the time taken in that displacement. That is called average. This is average velocity. And in terms of position, this is equal to final position of the object minus initial position of the object divided by time. This is the notion of average velocity, and it just like, since displacement depends on direction of motion of the object, so is velocity. Velocity is a average velocity is a vector quantity. Similar to instantaneous speed, there is a notion of instantaneous velocity. It is velocity at any particular instant. We will not define the mathematical equation of instant velocity because you require knowledge of calculus. So we will not define instantaneous velocity. Now we have defined speed, we have defined average velocity. Now there is a concept called uniform and non-uniform motion. What is meant by uniform motion is object covers equal distance in equal time interval. That is, if speed of the object is constant. Object is constant. Then we say that motion is uniform motion. Then we say that uniform motion is taking place. It is also called motion with uniform velocity. Motion with, this is sign up with uniform velocity. Now what is non-uniform motion? Object is said to be having a non-uniform motion if it covers unequal distances in equal interval time. Equal interval of time. That is, if the speed of the object is varying. If speed of the object is varying, then we have non-uniform motion, and such speed is called non-uniform speed or variable speed. Similar to non-uniform speed and uniform speed, we have a concept of uniform velocity or variable velocity. There are two concepts. Variable velocity. That is either magnitude in this uniform velocity, magnitude and direction remains same throughout the motion. Out the motion. However, for velocity, either magnitude or direction or both are changing with respect to time. This is called variable speed motion. Variable velocity. Then what is the difference between speed and velocity? velocity. Here we take speed, here we write velocity. So what are the differences? It is distance upon time, and this is displacement upon time. It is a scalar quantity, it is a vector quantity. It tells how fast object moves, and it tells how fast and in which direction the object moves. These are the differences between speed and velocity. With this we are near completion of the chapter called motion. Only one concept is left, that is weight and mass. I will take it in the next last lecture of motion of class 7, and then we will take some examples of the book prescribed. Thank you.